Hello everyone. In previous lectures, we were discussing about CPU scheduling. We have picked, first of all, first come first serve CPU scheduling algorithm. This works as the process which arrives first that will be executed first. Then we had picked that there is a possibility that longer bus time process arrived and it got time for execution. Hence, smaller processes need to wait more. So to overcome this situation, we moved into the next algorithm, that is shortest job first algorithm, and we have picked the both variation, preemptive version and non-preemptive version of it. Now, what is non-preemptive? Non-preemptive says that once any process has started execution into the CPU, it will not move outside. It will complete its execution. Preemptive says that system or operating system can switch out that process from the CPU and bring new process in without completion of its task. So that was preemptive and non-preemptive version, and we had picked that how shortest job first works on non-preemptive version and preemptive version. So we had completed shortest job first algorithm, and we had picked that there are two major disadvantages of shortest job first. The first major disadvantage is that how system will know the exact burst time, because shortest job first primary criteria to implement shortest job first is burst time or CPU running time. Now, mm, nobody can say that, or nobody can predict the exact burst time. How the system will know what is the exact burst time of process or how much amount of time process wants to execute. So that is the major disadvantage of shortest job first algorithm. Hence, generally it is called that it is not feasible to implement shortest job first algorithm since it is dependent upon the burst time. So, is there any way to implement this algorithm? And the answer is yes. How? That is, now we have several mechanisms to predict value of burst time. If somehow I can predict the value of burst time, then I can utilize or I can implement the shortest job first algorithm. Now, how to predict the value of burst time? It, there are so many ways I can predict the value of burst time. So I am going to present one small way through which you can utilize the prediction and predict the value. So I'm going to use the exponential function here. That is, suppose mm, a m plus 1 is equal to alpha actual value plus 1 minus alpha predicted value in past. This is one equation through which I can predict it. Now, how to utilize it? So, suppose let's take one example that at the start I am assuming the process, since I don't know that suppose I got one process X. I want to check that how much amount of burst time that process will use for execution. Suppose X process arrived. Now, if I want to implement SJF, then I need to give the burst time of X. So how to give burst time of X? So at the start, what I'll do, since nothing is known, so suppose I have predicted the value 10. Since nothing is known, now this is the only predicted value. Now, in original, suppose this process has executed for 14 unit of time. Now I got the actual value. Now, if next time this process X will arrive, now I have the both things as per my formula, that is actual value and the predicted value in the past. Now, what is alpha? Alpha is here smoothing function, and let's consider this as zero point 0.5 as an standard. I'll also tell at the end that why zero point 0.5 I have taken. So let's try to solve this thing. Now, because I have previous predicted value is 10 and current original value is 14, so what could be the next predicted value which that process can execute? So I have taken zero point 0.5 into 14 plus zero point 0.5 into 10. So this becomes 7 plus 5, that is 12. So my next predicted value is 12. Now suppose after this prediction, now on the basis of this, my system will schedule all the this process. Now let's assume that after prediction, this process has executed only 8 unit of time. Now, how to predict the next time, how much amount of time it will execute? So I'll take 12 and 8. This is purely diagonal way I'm going to take. Now, let's check again the value. 0.5 plus, sorry, 0.5 into 8 plus 0.5 into 12. So this becomes 4 plus 6. Now that is 10. So system has readjusted 8 into 10. Now you can see that my prediction as per my actual value, it is adjusting the value of my predicted one. Earlier, since my prediction got little bit lower, so next prediction got higher value. After that, because original value got lower, so system has adjusted it up to 10. So in this way, my prediction is working and it will produce value each and every time that process will arrive, and my system wants to schedule for the shortest job first. So in this way, I can get the predicted value, and on the basis of that predicted value of each and every process, scheduling of shortest job first will be performed. So that is how, by utilizing the prediction, I can implement the shortest job first. Now here, as I have mentioned earlier, that I have taken value of alpha is zero point 0.5 as an standard. Now, what will happen if I take value of alpha is 0? And what will happen if I take value of alpha is straight away 1? Why I have taken zero point 0.5 here? Now, as you can see, if I take value alpha 0, value alpha 0 means this complete portion, actual value portion will become 0. Means I am not going to consider the previous value of execution. If alpha is 0, it says that there is no relation between previous execution and the current execution. system is not going to consider the previous execution of this particular process. That is the meaning of alpha is equal to 0. And what is alpha is equal to 1? What this particular thing is saying? This saying that this is 0. Since this become 1 minus 1, so this will be 0 and this will be the 1. So it says that do not consider your prediction. It says that I cannot work on the predicted value. I am only going to consider the actual value, whatever it is. So my system is quite rigid in both the terms. One says do not consider the actual value, only consider the predicted value. Second one says do not consider the predicted value, only consider the actual value. So the thing which I have picked here, and we have analyzed that each and every time my system is getting readjusted, if actual value is high and previous prediction was low, so my value get little bit higher, otherwise my value get little bit lower. So my system is continuously readjusting it. Now if I have alpha 0 or alpha 1, that adjustment is gone. You have only fixed value. Either you are dependent upon actual value or you are dependent upon predicted value. So to give both as an equal weightage, I have considered alpha is equal to zero point 0.5. If you want to give weightage to any specific thing more, then this zero point 0.5 will get changed towards the value for which you want to give the additional weightage. Suppose you want to give weightage of actual value to 80% and predicted value to 20%, then alpha will become zero point 0.8. So in this way, you can change it. So that is how I can provide different uh, predictions for any specific process. So I hope you got that how to predict values for any particular instance and how utilize prediction for implementation of shortest job first. So that is overall shortest job first. Now that was the one disadvantage. The second disadvantage which we had covered, that was that what happened if any higher priority or system process arrived. Without that execution, no other process can execute. But since bus time of that process is higher, then this particular algorithm will not consider it. So what to do? So that is our next algorithm, and that is priority algorithm, that we need to provide external priority to the processes on the basis of their additional factors. So that is the primary aspect of our next algorithm, that is priority, which is again we have designed that algorithm from the disadvantage of previous algorithm, that was shortest job first. So in next class we will discuss the priority scheduling.